Robert Henke, the electronic music pioneer behind Monolake and a co-founder of Ableton Live, is renowned for his meticulous sound design that emphasizes subtlety, spatial depth, and controlled dynamics. His records often feature rich, embodied soundscapes, where embodiment refers to a full, immersive sonic presence that feels organic and three-dimensional, achieved through techniques like granular synthesis, physical modeling, and minimal processing. This guide expands on your query by providing a comprehensive tutorial on mastering audio to your specified parameters, an integrated loudness of -14.01 LUFS, a standard for streaming platforms like Spotify. True peaks capped at -6 dB for ample headroom and avoiding clipping, and a sound profile referencing pink or white noise for balanced frequency distribution. We'll favor tools from a development perspective, such as programmable environments like Max/MSP or Python scripts, allowing for custom control. Additionally, we'll highlight training resources on social media for learning these techniques. This approach draws from Henke's philosophy of simplicity and restraint, avoiding overcompression to preserve dynamics, as he has critiqued in interviews. By using dev-oriented tools, you gain full control over the entire dynamic, meaning you can script or patch every aspect of compression, EQ, and normalization for repeatable, customizable results. Key concepts and specifications explained. Before diving into the process, let's break down the targets. Integrated loudness, -14.01 LUFS. Loudness units relative to full scale, measures perceived loudness over the entire track. -14 LUFS is a common target for streaming to prevent volume normalization artifacts. It's more perceptual than RMS or peak levels. True peak, -6 dB. True peaks account for intersample peaks that can cause distortion in playback. Capping at -6 dB is conservative. Most standards recommend -1 dB TP, providing headroom for dynamics and preventing clipping during format conversions. Pink/white noise sound profile. Pink noise has equal energy per octave, rolling off at -3 dB per octave, sometimes adjusted to -4.5 dB/oct for mixing. It's used as a reference for EQ to achieve a natural balance, brighter highs and warmer lows. White noise is flat, equal energy per frequency, useful for testing but less common in profiling. Matching your mix to a pink noise curve ensures proper embodiment, giving the sound a full-bodied, even spectrum without harshness, similar to Henke's ambient textures. Dynamics control. This involves compression, expansion, and limiting to manage the dynamic range, difference between quiet and loud parts. Henke advocates for minimal intervention to keep sounds alive. Why like Robert Henke's records? Henke's work, such as in Ghosts or Signal to Noise, features controlled yet expansive dynamics, often built with custom Max/MSP patches for granular and physical modeling synthesis. His approach avoids loudness wars, focusing on depth over volume. Tools from a development perspective. Favoring programmable tools allows customization beyond GUI plugins. Here's a comparison. Tool description pros for DevCon's relevance to specs. Max/MSP visual programming environment for audio/MIDI. Henke uses it extensively via Max for Live in Ableton. Build custom patches for dynamics, EQ, and noise referencing. Steep learning curve, not free, though Pure Data is an open-source alternative. Ideal for embodying sound through granular synthesis like Henke's Granulator 2. Python with libraries like PyLoudNorm, Sippy, NumPy, script-based audio processing. Full automation. Integrate LUFS normalization and FFT for pink noise EQ matching. Free and extensible. Requires coding, no real-time preview. Perfect for batch mastering to exact LUFS/peaks. Generate/reference noise profiles. Ableton Live plus Max for live. Henke's primary DAW for production. Combines dev, Max patches, with workflow. Paid, less pure dev than standalone scripting. Dynamics control via built-in tools, extensible for custom noise profiling. FFmpeg normalize, Python wrapper, command line tool for loudness normalization. Scriptable for pipelines, handles LUFS and peaks. Limited to normalization, not full EQ. quick for -14 LUFS and -6 dB peaks. We'll focus on Python for a dev-centric example, as it allows complete control without proprietary software. Step-by-step guide to mastering. Assume you have a mixed stereo wave file. Install Python libraries. Pip install pyloudnorm sound file numpy sippy pydub. Note, in a real env, but our code_execution tool has some of these. Prepare your environment and calibrate. Use pink noise for room/speaker calibration. Generate pink noise at -20 dB RMS and adjust monitors to 79 to 85 dB SPL using an SPL meter. This ensures accurate perception of dynamics. Analyze and normalize loudness, LUFS and peaks. Use pyloudnorm to measure and normalize to -14.01 LUFS with true peak limit. Apply dynamics control. Use compression sparingly, Hinky style. EQ to pink/white noise profile. Analyze spectrum with FFT and match to pink noise curve, -3 to -4.5 dB/oct. Use tools like Balink EQ logic and code. Divide into bands, compare to reference. Embody the sound, Hinky-inspired synthesis. Add spatial elements. Use max/MSP for granular patches, e.g., Hinky's granulator. In Python, simulate with overlap add for reverb/delay. Export and test. Measure final LUFS/peaks to confirm. Training resources on social media. To learn these techniques, leverage social media for tutorials. YouTube. Search for Robert Hinky Max/MSP tutorial. Watch Max for Live, the monolake granulator for granular sound design. Also, mixing and mastering with pink noise, Ozone 9 EQ match for noise profiling. Hinky's playlist on advanced techniques includes limits and synthesis. Reddit. Subreddits like r/edproduction discuss LUFS and limiting. r/we are the music makers for pink noise EQ threads. X. Twitter follow at Robert Hinky for insights. Search for #MaxMSP #sounddesign or #audio mastering LUFS. Users share scripts and tips. Facebook groups. Max/MSP Jitter group for Hinky-inspired bass/synth tutorials. Practice iteratively. Start with Hinky's free operator presets in Ableton, then script in Python for mastery. This dev-focused path ensures you embody Hinky's ethos of innovation and control.